Okay. The next few lectures are going to be over Chapter 4, and the PowerPoint is called Communities and Biomes, and as always, it's found on my website. 4.1, page 96, talks about climate, and you're going to have to know the difference between weather and climate, greenhouse effect versus global warming, and then ozone depletion. You'll be reading about some of this, and we'll discuss some of this. Some of this will actually be discussed more again in Chapter 5 or 6. So we're going to talk about it now, and then we'll talk about it again. But weather is the state of the atmosphere with respect to heat or cold, wetness, dryness. Climate is the average course or condition of the weather at a place, usually over a period of years. So weather is like what's happening now. Climate is what you get over years. You talk about the climate of an area. Greenhouse effect versus global warming. Global warming is the fact that our Earth has increased 1 to 2 degrees Celsius. Their average climate has increased in certain areas. That in turn has caused the greenhouse effect. You have an increase in temperature due to carbon in the air. Okay, the carbon in the air then is trapped. Heat can't get out. So then that causes the Earth to heat up. I think I might have said it backwards. The greenhouse effect causes global warming. I'll say it again. The greenhouse effect causes global warming. The greenhouse effect is where that carbon is trapped in the atmosphere. Heat can't get back out, so the Earth heats up. The Earth heating up is global warming. Ozone depletion has nothing to do with the greenhouse effect or global warming. It's two different issues. CFCs, or chlorofluorocarbons, have depleted the ozone. This is a chemical used to be found in aerosol spray, Freon, things like that, which I think as of now we're not supposed to have anything with CFCs in it, at least in the United States. It's been outlawed. But the CFCs built up in the atmosphere caused a hole in this layer of the atmosphere known as the ozone layer. The ozone layer protects us from UV light. That hole has allowed more UV light to get in and can cause an increase in skin cancer. That depletion of that ozone, or that layer of protection, has been because of a chemical known as CFCs, chlorofluorocarbons. Habitat versus niche. I mentioned habitat in an earlier lecture. It's a place in which an organism lives, a tree, a lake, maybe your house. Niche is the role a species plays in its community. It's the total way of life. Its niche would include what it eats, when it reproduces, where it lives, how it interacts with other organisms. A niche is the overall way of life of an organism. A niche is determined by the tolerance limitations of an organism, or a limiting factor. A limiting factor, any biotic or abiotic factor that restricts the existence of organisms in a specific environment. Factors that can limit one population in a community may indirectly affect another. So limiting factor, a living and non-living things that can restrict the existence of an organism in a specific environment. Here in Iowa, we would not see polar bears because of the temperature. It's too warm. A limiting factor for polar bears to live in Iowa would be the temperature. Examples of limiting factors would be the amount of water available. If someone needs lots of water and there's not water, they couldn't live there, so it's a limiting factor. It's going to limit them living in an area. The amount of food, temperature, the amount of space, and the availability to be able to mate. Those are things that can limit organisms living in a particular area. So there's an optimum range for certain fish, optimal temperature. If they get out of those areas, you won't see the fish there because there won't be food. There won't be the right temperature. And if there's no food, there's no animals, so there'll be no one to mate with. Competition, predation, and keystone species. Competition is, fighting for food, shelter, water. All animals compete. You can compete with the same species, or competition could be between species. You can compete with the same species for a place to live, for food, to be able to mate. Or it could be between species, two birds competing for the berries on a tree. Keystone species is a species that can cause dramatic changes in an ecosystem. Something happens to that organism, it's going to affect all other living creatures in that area. Keystone species. We've talked a little bit already about symbiotic relationship. A symbiotic relationship is a close relationship between two organisms, and you should already know the three types: commensalism, parasitism, and mutualism. Commensalism, one species benefits and the other is neither harmed nor helped. Orchids living on a tree. Orchids in the rainforest, the soil is very poor and acidic, so a lot of plants cannot grow in that type of soil, so they actually grow on the trees. The orchids are helped because they have a place to live. Nothing happens to the trees. An orchid is known as an epiphyte, a plant that grows on another plant upon which it depends for mechanical support, but not for nutrients. Epiphyte. But this is an example of commensalism. Another example of commensalism are those fish that follow sharks around. They get the leftover food from the shark. They don't hurt the shark, they don't help the shark, but the fish are being helped because they're getting food. And commensalism, one species benefits, the other is neither harmed nor helped. Polar bears and cyanobacteria. The cyanobacteria live in the polar bear's fur. Doesn't harm the polar bear. The cyanobacteria have a place to live. Another example of symbiotic relationship is parasitism. One benefits, that's the parasite, and the other is harmed, the host. So parasite-host relationship, again, here's a perfect example, the tick. The tick is considered a parasite. Tapeworms are considered parasites. Here is a lamprey on the outside of a fish. A lamprey is a jawless fish. It sucks the blood of other fish. So fleas, again, another example. So we have lampreys, leeches, fleas, ticks, tapeworms are all parasites. The parasite gets help, the host is harmed and could possibly die. Mutualism. This is where both of them benefit from each other. The birds on that rhinoceros clean the rhino. They're usually cleaning their teeth, which helps the rhino to have clean teeth. So they're helping each other out. The bird's getting food, the rhino's getting his teeth cleaned. Another example of a mutualistic relationships where both of them benefit is something called lichen, and lichen we'll see that out at Wilson Lake. A fungus and an algae live together. The algae goes through photosynthesis, produces glucose and oxygen. The fungus can live off of that. And then the fungus gives algae a place to live. They need each other. If one dies, the other one dies. They're helping each other out. Here's some more pictures of lichen. The algae and this fungi living together so they can both survive. So again, we have commensalism, parasitism, and mutualism. In commensalism, one gets benefit, nothing happens to the other. Parasitism, one is harmed and one gets benefited, and mutualism, they're helping each other out. Okay, succession. Orderly, natural change and species replacements that take place in a community over time. So a community changing over time is known as succession. It occurs in stages. Different species at different stages create conditions that are suitable for some organisms and not suitable for others. It's really difficult to observe because it happens over a very long period of time and it's a very slow type of process. There are different types of succession. There's primary succession, where initial colonization of a new site, lava from a volcano, like an avalanche would wipe everything out. The first thing to show up after that is known as a pioneer species, the first species in an area, and oftentimes it's lichen. Climax community is a stable, mature community that undergoes little or no change in species. Over time, as a community or organisms change and develop, areas become forests of vines, trees, and shrubs inhabited by birds and other forest-dwelling animals. Gradual change over time. So primary succession is new, or the initial colonization of a new site. There's kind of an example: exposed rocks, lichens and mosses grow, grasses, herbs, and shrubs can grow. Then you have certain trees finally starting to grow in an area. So you have pioneer species colonize, growth continues. Pioneer organisms will die, decay into the soil, making the soil nutrient rich. The presence of soil makes it possible for weedy plants and small plants and some insects to finally show up. The soil then builds up even more. You have seeds, larger plants and trees, shrubs start to grow, and then you have the forest there with birds and animals. Then there's something called secondary succession, sequence of changes that take place after a community is disrupted by natural disasters or human actions. So not everything was kind of wiped out. Some stuff got disrupted, it's just been disrupted, and then you'll slowly have change again. Again, it's a gradual change over time. The area previously contained life. It already contained soil. It was just disrupted by maybe a hurricane or a tornado. You're going to have different types of pioneer species this time around. May have same climax community because of the similar climate in the area, the ending result or climax community could possibly be very similar as to what it was in the beginning. This takes place a lot faster than primary succession because the soil is already there. The soil wasn't wiped out in the natural disaster. So it's going to take not as much time. So again, we have primary succession, secondary succession. Primary succession is an initial colonization of a new site when the area's been completely wiped out, a lot of times by lavas or avalanches, or maybe even like a mudslide. Secondary succession is just a disruption in the community due to natural disaster, earthquakes, hurricanes, or possibly sometimes human action.